Okay, so now I'm on step 4 and I have the option of the classical or the p-value approach, and I don't believe we were told which way to do it, so I'm going to do p-value. It's always simpler. So the p-value would be equal to t dot dist dot 2t, and then it's that value, the test statistic we just found, comma, and our degrees of freedom, remember, is the same for all of these because they're all 70, so it should be 69 for each one of them. Right, so 69, or I could just do this. That guy minus 1. Cool. The 2 dist thing, 1 second here. Oops. If you have equals t, old school Excel, I'm just trying to think, it's t dist, and then I think it would be this, comma, degrees of freedom is 70, take away 1, comma, two-tailed. There you go. That's how to do it with the older software. Okay, so this value is obviously lower than 0.05. So step 5, which is all we were really interested in, we would reject H naught. P is less than alpha. All right. So if I go back to the problem here, and of course, your problem, I don't know if it'll be less than alpha. You'll have to double check. So if we reject H naught, what does that mean for step 6? That means that there is enough evidence to support the claim that the mean CBCL scores were different for the RAP group and the control group. Right? So that's what you're finding here, because you're finding the difference in this mean and this mean, right? The 11.8 and the 9. You found that they're significantly different. So you'd say, yep, over here. Yay. Did that. Is it necessary to check normality? No. The reason being, here, the populations are drawn normally distributed, or the sample sizes are large. So our sample sizes were all 70s, right? So big fat no. There we go. And I can even write it down here if I wanted. So D, the answer was, oopsie, no, because the sample sizes were all greater than 30. Cool. Next. Now, use an ANOVA procedure. Well, that's going to be a little bit trickier. So let me first get up the formulas for that. Let me bring up the notes. Hold on 1 second. I take it back. I had to bring up the book here just to help, because otherwise you'll get lost. So here we go. So the F statistic is the mean square due to due to treatments over the mean square due to error. So you're going to have to find MST and MSE. And now both of those, there's little formulas for them. MST is actually SST divided by your degrees of freedom, and MSE is on the previous page down here. Where, oops, right there. So you have to find this guy right here, that formula. Okay, well, it looks really horrid, but Excel actually finds it pretty quickly for you. So let me see if I can find them over here. So the first thing we're going to have to do is we're going to have to find X bar overall, which is going to be equal to the average of these three. They're all equal in number. That's why if it had been like one of these was 70, one of these was 71, or whatever, you'd have to do a weighted mean. But since they're all equal, 70, you can just add them up and divide by 3, which is what I did with the average formulas right there. Now I'm going to have to find, all right, so I'm actually going to not start with this one. I'm going to start with the other one, and I'll find the next one. So I'm going to find x1 minus x bar, x2 minus x bar, and 3. So this is going to be x bar I minus x bar, okay, which is equal to this minus that guy. Give him dollar signs, all right? And then I'm actually going to square it. So put it in parentheses and square it. It should look pretty familiar because you sort of did it back in section 3.3 when we found a variance for a weighted mean. All right, so there's that part of it. I'll be back to find the next part. So we found part of that numerator up here. So we'll find the rest of it in the next video.